November 13th, 1942. The Kumusi River, Papua New Guinea. The river was swollen from days of tropical rain. Brown water roared between jungle banks, carrying tree trunks and debris at a speed that made even strong swimmers hesitate. The air hung heavy at nearly 90% humidity. Rain fell without warning, then stopped just as suddenly, leaving steam rising from the soaked earth. Australian engineers stood waist-deep in the current. Their uniforms were dark with water and sweat. Leeches clung to their legs. Mosquitoes hovered in clouds around their faces. Every movement was slow, deliberate. They were not building in safety. Japanese snipers were positioned somewhere in the trees across the river, less than 800 meters away. Each hammer strike echoed through the jungle. Metal on timber. Rope pulled tight. Axes biting into wet wood. Every sound carried. A single rifle crack broke the morning air. The bullet struck the water 5 meters from a sapper's shoulder. No one spoke. They continued working. The smell of rotting vegetation mixed with the sharp trace of gunpowder that lingered after distant exchanges of fire. Cold river water numbed their legs, yet sweat ran into their eyes under steel helmets. Malaria had already taken its toll on many of them. Several men shivered with fever, even as they worked. Upstream, thunder rolled again. The Kumusi was rising. This was not routine engineering. In 72 hours, a bridge had to stand here. Not a footbridge for patrols. Not a temporary rope crossing. A structure capable of carrying thousands of men with rifles, machine guns, mortars, and supplies. If it failed, 6,000 Allied troops would remain trapped on the western bank. Behind them, Japanese forces were regrouping. Patrols were already moving through the jungle. Intelligence suggested they were only 3 kilometers away and closing. If the Australians could not cross quickly, they would be caught between river and enemy. There was no alternative route. The terrain on both sides was dense, mountainous jungle cut by ravines and flooded creeks. Air resupply was limited and unreliable. Boats were impossible in this current. The river was the last barrier. A burst of rifle fire came from deeper in the trees. The infantry perimeter answered. The engineers did not look up. They drove another timber stake into mud that shifted beneath their boots. Time was not measured in hours now, but in structural progress. Every log set in place was another step toward survival. Every delay gave the enemy more opportunity to close the gap. The men understood this without needing it explained. One mistake in measurement, one misjudged load, one support placed at the wrong angle, and the entire force would be trapped. The Kumusi River did not care about military plans. It surged and twisted, undercutting its banks, dragging at anything placed within it. The jungle pressed in from every direction, offering concealment to the enemy and no comfort to the builders. The engineers worked in silence except for necessary orders. They were not building for recognition. They were building to prevent annihilation. By dawn on November 16th, either a bridge would stand over the Kumusi River, or 6,000 Australian soldiers would face isolation, starvation, and encirclement. This was not simply construction under fire. It was the narrow line between evacuation and destruction. By November 1942, the campaign along the Kokoda Track had been underway for 4 exhausting months. What began as a Japanese advance toward Port Moresby had turned into a grinding struggle across some of the most difficult terrain on Earth. The Owen Stanley Range rose steeply through Papua New Guinea, peaks climbing to more than 13,000 feet. Narrow tracks wound over ridges and through valleys choked with jungle so dense that daylight barely reached the ground. Rain fell almost daily. Rivers flooded without warning. Supply lines stretched beyond practical limits. In August and September, Japanese forces had pushed south toward Port Moresby. By October, exhausted Australian units had halted the advance and begun forcing the enemy back. It marked Japan's first major land setback of the war. Yet it was not a collapse. The withdrawal was controlled, deliberate, and often fierce. The Japanese did not run. They fought for every ridge and river crossing. Now the Australians were pursuing northward toward the coast. Their objective was clear: prevent Japanese forces from consolidating at their strongholds near Buna and Gona. If those positions were fortified and supplied, the campaign could drag on for months. Geography dictated the pace of operations. Papua was not simply hostile, it was indifferent. Mountains, mud, insects, and disease claimed nearly as many casualties as combat. Malaria, dysentery, and tropical ulcers weakened units that were already undersupplied. Every crate of ammunition or food had to be carried by hand, dropped by aircraft, or dragged along narrow tracks. The Kumusi River lay directly in the path of the Australian advance. At this point in the campaign, it represented the last major natural barrier between the withdrawing Japanese formations and the coastal defensive line at Buna to Gona. If Japanese troops crossed first and established prepared positions on the northern bank, they could transform the river into a defensive wall. A delay of even a few days would matter. Australian units were already operating at the extreme limit of their logistics. Rations were short. Ammunition reserves were finite. Hundreds of sick and wounded men required evacuation southward. Without a crossing, those men would remain stranded on the wrong side of the river. At the same time, Japanese engineers were reported to be destroying previous crossing points and preparing defensive positions along likely approach routes. Intelligence suggested that elements of the South Seas Detachment, experienced jungle fighters numbering in the thousands, remained active in the immediate region. The Australian 7th Division had carried the weight of much of the campaign. Its soldiers were hardened by months of mountain warfare. Many had marched, fought, and retreated across the same terrain earlier in the year. They were experienced but worn down. Supporting them was the 2-6 Field Company of Engineers, roughly 150 men trained not only to fight but to build under fire. Their tasks extended beyond bridges. They cut tracks through jungle, built supply routes, cleared obstacles, and repaired damaged infrastructure. Without them, infantry could not advance. Control of Papua New Guinea had broader meaning. If the Japanese secured the northern coast and maintained pressure toward Port Moresby, Australia itself remained under threat. Airfields in Papua could project power southward. The outcome of this campaign would determine whether the Pacific War continued to press against Australia's doorstep or began to recede. At the Kumusi River, strategy narrowed to a single crossing point. Whoever controlled that crossing would dictate the tempo of the next phase of the war in Papua. The river was not merely a geographical feature. It was a decision point in a larger struggle. The Australians needed momentum. The Japanese needed time. Between those two objectives stood a flooded river and a handful of engineers with limited tools. The broader war pressed down on that patch of mud and water. The next 72 hours would shape whether the pursuit continued or stalled under the weight of terrain and enemy resistance. Captain Hugh "Doc" Whittington was 32 years old when he stood on the bank of the Kumusi River. Before the war, he had been a civil engineer in Sydney. His work was precise and predictable. He calculated load tolerances for suburban bridges, reviewed blueprints, inspected steel and concrete that arrived on schedule. His world had been orderly. In 1940, he enlisted. A year later, he was commissioned as an engineer officer. The transition from drawing board to jungle was abrupt. By November 1942, he no longer resembled the well-fed professional who had left Australia. He had lost 18 kilograms since arriving in Papua. At 183 centimeters tall, he now weighed barely 68 kilograms. His cheeks were hollow. Malaria returned in cycles, leaving him shivering one day and drenched in sweat the next. He refused evacuation more than once. Among his men, he was known simply as Doc. The nickname came partly from his education and partly from the way he studied structures as though diagnosing illness. He carried calculations in his head. He could estimate stress loads without paper, visualize how weight would transfer through timber and rope. That ability had earned respect. So had something else. He never ordered a task he would not perform himself. If piles had to be set in mud under fire, He went first. If ropes had to be tensioned over rushing water, he took a position on the line. His standards were strict. Some sappers said he demanded too much, but they also knew he demanded it equally of himself. Within the 2/6 Field Company, several men stood out. Sergeant Bill Ironbark Morrison was 28, a former timber worker from Queensland. Years of felling hardwoods had given him an instinctive understanding of trees. He could study a trunk and judge its grain, strength, and balance. In jungle operations, that skill mattered more than theory. Corporal Tommy Chen was 24, born in Melbourne to Chinese immigrant parents. He had volunteered early. Rope work and cable tensioning were his specialty. He tied knots quickly and securely, even in rain or darkness. He had learned basic principles of navigation from his grandfather, who had worked on coastal vessels. Chen faced occasional prejudice from other units, though not within his own company. In the field, competence mattered more than background. The rest of the sappers formed a cross-section of civilian trades: carpenters, farmers, steelworkers, mechanics. The average age was 26. Many were suffering from malaria or dysentery. Tropical ulcers ate at their legs. Sleep came in short intervals between alerts. Heavy machinery was absent. There were no cranes, no engines, no prefabricated components. Everything was done by hand: axes, saws, rope, pulleys, muscle. In other circumstances, such a project would have required weeks of preparation and specialized equipment. They had days. The company had already achieved tasks considered improbable. Weeks earlier, they had carved thousands of steps into steep terrain to move troops and supplies over a mountain ridge. That effort had left hands blistered and shoulders raw, but it had strengthened trust within the unit. Combat engineering had become routine. Gunfire during construction no longer caused panic. Orders were often communicated with gestures rather than words. 3 months of shared danger had created quiet coordination. For Whittington, the Kumusi crossing carried additional weight. 6 weeks earlier, a temporary bridge on the Kokoda track had collapsed during heavy rain. 2 of his men had been killed. Though conditions had been unstable, he blamed himself for allowing the work to proceed too quickly. He wrote letters to the families. He carried copies of those letters in his pack. Before leaving for the northern advance, he had told a fellow officer that he intended to bring the rest of his men home alive. It was not bravado. It was an intention shaped by loss. Now he faced a contradiction. The bridge at the Kumusi had to be built faster than any previous structure in the campaign. Speed increased risk. Delay increased danger. The calculations in his head offered probabilities, not guarantees. His men watched him for signs of doubt. They did not need speeches. They needed confidence that the structure would hold when thousands stepped onto it. Whittington understood that leadership in this moment required more than engineering skill. It required steady behavior under uncertainty. Behind him stood 150 exhausted engineers. Beyond them, thousands of infantry waited. In front of him, a flooded river moved with indifference. The burden of connecting those 2 banks rested on his decisions. The Kumusi River, at the selected crossing point, measured approximately 42 meters from bank to bank. After several days of tropical rain, the current moved at an estimated 8 to 10 kilometers per hour. The surface appeared chaotic, but the true danger lay beneath. Depth varied from 2 to 4 meters, and the riverbed consisted of mud mixed with loose stone that shifted under pressure. There was no solid bedrock. Previous footbridges built by local villagers had long since been washed away. The only colonial-era crossing in the area had been destroyed during the Japanese withdrawal. What remained were fragments of timber scattered downstream. The engineers possessed no steel beams, no prefabricated sections, and no motorized equipment. Their tools were axes, hand saws, ropes, and a limited number of metal bolts salvaged from earlier projects. Timber had to be cut directly from the surrounding jungle. Time was the most unforgiving constraint. Intelligence indicated Japanese reinforcements moving from the coastal region toward the river. 72 hours was the maximum window before the crossing point would likely come under sustained attack. After that, the site could become a fortified position defended by artillery and machine guns. The chosen construction area lay on a bend in the river, offering minimal natural cover. From elevated ground across the water, the entire work zone was visible. At least 4 enemy snipers had been identified in concealed positions. Their effective range covered the full width of the riverbank. Probing attacks by Japanese rearguard units occurred at irregular intervals, often every 6 to 8 hours. Each contact tested the Australian perimeter. Each firefight consumed ammunition and energy. Reports also suggested that at least 2 Japanese mountain guns were within potential range. They had not yet fired on the crossing site. That silence was not reassuring. The bridge itself had to carry more than light foot traffic. Fully equipped infantry weighed close to 90 kilograms per man when weapons and packs were included. Stretcher parties would carry wounded across. There remained the possibility that light vehicles, weighing over a metric ton, might attempt the crossing if the structure allowed. The foundation problem was severe. Without bedrock, vertical piles would sink unevenly. Mud could shift overnight, altering load distribution. Traditional suspension methods required anchors and materials not available. Any misjudgment in weight balance could twist the structure apart. Weather complicated every decision. Afternoon storms were common. In a matter of minutes, the water level could rise nearly half a metre. A single heavy downpour could undo hours of labour. The river had already demonstrated its power by sweeping away previous crossings. Human endurance was another limiting factor. Many of the engineers were physically depleted. Malaria cycles caused fever and weakness. Dysentery drained strength. Several men could barely stand for extended periods, yet none requested evacuation. Fatigue reduced concentration, increasing the risk of mistakes. Failure carried consequences beyond embarrassment. If the bridge did not stand, 6,000 Australian troops would remain isolated on the western bank. Supplies were already limited. Estimates suggested no more than 8 days of rations and perhaps 5 days of sustained ammunition reserves. More than 800 sick and wounded required evacuation. Field medical stations were operating beyond capacity. Without a crossing, the injured would remain exposed to both disease and advancing enemy forces. Strategically, the collapse of the pursuit would allow Japanese forces to reorganize and entrench along the northern coast. The momentum gained over months of difficult fighting could be reversed. For Australia, the implications extended beyond Papua. There was an additional complication that emerged during timber inspection. Much of the local wood appeared solid from the outside, but was internally weakened by termites. Damage was often invisible until a trunk was cut open. This introduced uncertainty into load calculations. A single compromised beam could initiate structural failure. Whittington recognized that standard bridge designs would not suffice. Conventional solutions required materials and anchoring conditions that did not exist here. Any design would need to account for shifting foundations, unpredictable water levels, and uneven timber strength. He also understood another reality. His men looked to him for certainty. Visible hesitation could undermine morale. Yet confidence could not replace physics. On the bank of the Commusi River, the task was clear, but the solution uncertain. The engineers faced not one obstacle, but a chain of interlocking problems: environmental, tactical, structural, and human. They had limited tools, limited time, and no margin for error. And the river continued to rise. Dawn, November 13th. Captain Whittington entered the river with Sergeant Morrison at first light. Both men carried measuring rope and marked stakes. Rifle shots cracked from across the water as they worked, bullets striking wide at first, then closer as the range was corrected. The initial readings were discouraging. The water level was approximately 30 centimeters higher than reported. The current pressed harder against their legs than expected. Any structure would endure greater lateral force than previously calculated. Back on the bank, Whittington made his decision. A traditional suspension bridge would not hold without reliable anchors. Instead, they would attempt a cantilever design, extending heavy timber arms from each bank, counterweighted with mass and secured by rope systems. It was an untested solution in combat conditions. Teams moved into the jungle to locate suitable trees. More than 60 logs were required, each of specific diameter and length. Felling and dragging a single trunk to the river could take 2 hours. Men worked in pairs, hacking through wet timber while glancing toward the tree line for movement. Before midday, the first casualty occurred. Sapper Davis was struck in the shoulder by a sniper round while marking a felled trunk. He survived, but the sight of blood in the mud changed the tone. The threat was no longer abstract. By afternoon, foundation work began. Attempts to sink vertical piles directly into the riverbed failed. The mud was too soft. Logs tilted under pressure. Morrison proposed constructing submerged log cribs, rectangular frames filled with river stones to create artificial bases. Men dove into the murky water to assemble them by touch. Visibility was near zero. Each sapper could hold his breath for barely a minute before surfacing. The current battered them as they locked timber together below the surface. At 3 p.m., a thunderstorm struck. Rain hammered the jungle canopy. Within 20 minutes, the river rose nearly half a metre. One partially completed crib shifted and broke apart. 4 hours of work disappeared downstream. That night, at 11 p.m., a Japanese patrol tested the perimeter. The firefight lasted 20 minutes. 2 Australian infantrymen were killed. 5 were wounded. Construction paused only long enough to secure the line. Whittington lost his composure briefly, shouting for increased speed. Morrison intervened quietly, reminding him that exhaustion could kill as surely as bullets. At midnight, 24 hours had passed. Progress stood at roughly 15%. November 14th began with guarded relief. The remaining cribs had held through the night. Work resumed immediately. The cantilever arms began extending from both banks. Without surveying instruments, alignment posed a serious problem. Corporal Chen suggested a method using rope triangulation combined with reference to visible stars during breaks in cloud cover. It was imprecise, but workable. By early afternoon, exhaustion became visible. 6 men collapsed from fever and heat. Whittington refused to request replacements. Infantry could not be spared from defensive duties. At 2 p.m., an Australian counter-sniper eliminated one of the enemy marksmen. The reduction in accurate fire improved morale, though other snipers remained active. Another storm struck at 4 p.m. This time, the cribs held. The structure endured. Whittington ordered night work under shielded lanterns. The risk of attracting artillery was real, but delay was worse. At the 48-hour mark, the bridge was half complete. The most delicate stage remained, joining the 2 projecting arms over open water. By the morning of November 15th, a 6-metre gap separated the cantilever sections. Weight balance became critical. Morrison admitted privately that timber strength could not be fully guaranteed. There was no time for proper testing. Japanese reinforcements were reported 8 kilometres away, advancing steadily. The original 72-hour window had narrowed. Corporal Chen volunteered to crawl across a narrow log to secure a guide rope between the sections. A safety line was rigged, though few believed it would save him if the structure failed. At 5 p.m., he moved across the swaying timber. The bridge groaned but held. With the guide rope in place, heavier beams were pulled into position. Whittington crossed personally to test the alignment. Midway, a support timber split with a sharp crack. The span dropped approximately 15 centimetres before stabilising under counterweight tension. He continued walking. By late evening, artillery fire began landing near the western approach. Shell bursts shook the ground. One round landed within 10 metres of the structure but caused no direct damage. Through darkness and intermittent shelling, the engineers secured bolts, tightened lashings, and reinforced weak points. At 6:17 a.m. on November 16th, after 68 hours and 17 minutes of continuous effort, the bridge stood complete. It swayed over the swollen Kumusi River, imperfect and strained, but intact. 6,000 men were waiting. November 16th, 1942. 6:30 a.m. Mist still hung over the Kumusi River when the 1st Infantry Platoon formed at the western approach. Behind them, thousands of Australian soldiers waited in uneven lines, weapons slung, boots sunk in mud. Sporadic Japanese artillery fire echoed from the jungle. Captain Whittington stood at the near end of the bridge. He had tested it once. Now it would carry real weight. Colonel Morrison, commanding the division elements at the site, gave a simple order. "Get them across, now!" 40 men stepped forward in single file. Each carried full equipment: rifle, ammunition, pack, entrenching tool. The bridge dipped slightly under the first boots. Timber groaned as load transferred through rope and counterweight. Whittington instructed spacing. 1 man every few meters. Slow pace. No running. The crossing was agonizingly deliberate. Each soldier required 3 to 4 minutes to reach the opposite bank. At that rate, moving 6,000 men would take most of the day. Reports indicated Japanese reinforcements could arrive within hours. At 7:10 a.m., Captain Reed, commanding infantry at the western bank, confronted Whittington. He demanded acceleration. Delay would expose the entire force to attack. Whittington objected. The structure was not designed for double flow. Reed's response was direct. If the enemy struck before the crossing was complete, the bridge would be useless. At 7:15 a.m., Whittington allowed an increased pace under strict spacing conditions. The rate nearly doubled. The bridge responded with deeper, unfamiliar sounds. Low creaks replaced earlier sharp cracks. At 7:45 a.m., the Japanese attacked. Infantry fire erupted from concealed positions on the western flank. Almost simultaneously, artillery shells began landing closer to the river. The worst timing possible. Approximately 800 men were on the bridge or in immediate approach. A shell struck the water near midspan, sending a column of spray across the timbers. Soldiers instinctively bunched together. Sergeant Morrison ran onto the bridge shouting for order. He physically separated men, forcing distance between them. Another shell landed near the eastern bank. The concussion threw 2 soldiers into the river. One was pulled out by rope. The other disappeared downstream. Whittington faced a decision: halt the crossing and reduce stress, or continue under fire. He stepped onto the bridge. Positioning himself near the center, he began controlling movement directly. He counted seconds between footsteps. He recalculated load distribution as artillery bursts shook the structure. Corporal Chen joined him without instruction, taking position farther along the span to regulate flow from that side. At 8:12 a.m., a direct hit struck near the western approach. 11 men waiting to cross were killed instantly. More were wounded. Shrapnel severed 2 support ropes. The bridge twisted slightly, tension uneven. A main timber fractured along its grain, not completely, but enough to lower one side by nearly 25 centimeters. Chen realized the damage lay beneath him. If he shifted weight abruptly, the stress change could propagate the crack. He remained motionless. "Keep them moving," he called out. The crossing continued. From 8:15 to 8:45, artillery fell intermittently. Water from near misses soaked the structure, adding weight. Morrison organized emergency rope teams on the eastern bank, throwing reinforcement lines toward damaged sections. Whittington calculated rapidly. Roughly 2,000 men had crossed. Thousands remained. Japanese infantry fire was growing closer. At 8:30 a.m., he ordered a further increase in pace. The bridge protested audibly. Multiple beams cracked in succession. Each vibration traveled through the frame. On the western side, the rearguard was falling back under pressure. Japanese troops were closing to within a few hundred meters. By 9 a.m., discipline on the approach weakened. Men moved faster than instructed. Whittington could no longer regulate every step. Morrison shouted for Chen to withdraw. Chen shook his head. He understood the risk. At 9:10 a.m., the final rearguard platoon began crossing as enemy forces reached the riverbank. Japanese artillery delivered a rapid series of shells. One struck near the eastern support. The bridge lurched violently. At 9:14 a.m., the last Australian soldier stepped onto the eastern bank. For a brief second, the span held under diminishing load. Chen attempted to move. At 9:15 a.m., the structure failed. The central section twisted free. Cantilever arms tore from their anchors. Timber and rope collapsed into the rushing river below. Chen fell with it into the Camusi's current. The crossing was complete. The bridge was gone. 9:15 a.m., November 16th. The bridge disappeared into the Camusi River in a single violent motion. Timber, rope, and broken beams were swallowed by brown water and carried downstream. For a few seconds, there was only spray and silence between artillery bursts. Then shouting began. Captain Whittington and Sergeant Morrison ran along the eastern bank, scanning the current. Without hesitation, both men entered the river downstream of the collapse point. The current was still powerful, pushing debris and men alike toward submerged rocks and fallen trunks. Search parties moved along the bank, ropes in hand. At 10:47 a.m., nearly 90 minutes after the collapse, Corporal Tommy Chen was found approximately 400 meters downstream. He was tangled in loose rigging, unconscious but alive. His leg was broken. Several ribs were fractured. His body temperature had dropped sharply from prolonged immersion. When he regained consciousness later that day, his first question was simple. Did everyone make it? The count was completed by midday. 6,000 troops had crossed. 34 were killed during the crossing itself, most by artillery, some by small arms fire. 89 were wounded. The losses were severe, but the division remained intact. At 9:40 a.m., Japanese forces reached the western bank. They found no bridge and no means of immediate pursuit. Engineers on their side surveyed the wreckage, but could not establish a rapid crossing under Australian fire. The pursuit continued. Once the role was confirmed and the wounded evacuated, Whittington's composure gave way. Exhaustion and malaria overtook him. He collapsed and remained unconscious for 16 hours. In the days that followed, engineers examined the remains when the river level allowed. Analysis suggested that the fractured cantilever beam at 8:12 a.m. should have triggered total collapse far earlier. Under normal calculations, the structure had exceeded safe limits for over an hour. Morrison later remarked that the bridge had held longer than engineering theory predicted. Salvage operations recovered bolts, rope, and intact timber fragments for reuse elsewhere. Japanese patrols were observed inspecting the opposite bank. There were no exchanges of fire during those brief encounters. In the weeks after the crossing, Australian forces pressed toward the coastal strongholds at Boona and Gona. The ability to move intact units across the Camusi maintained momentum. The campaign would continue through the end of 1942 and into early 1943, ultimately ending in Allied control of the region. The strategic outcome was significant. It marked confirmation that Japanese ground forces could be defeated in jungle warfare. The threat to Port Moresby diminished. The broader security of Australia improved. The human consequences endured longer. Tommy Chen was evacuated first to Port Moresby and later to Australia. His leg healed, though he walked with a permanent limp. He received recognition for gallantry and returned to service the following year, despite medical concerns. After the war, he faced discrimination in civilian employment before securing steady work in railway bridge maintenance. He rarely discussed the Camusi crossing until late in life. Sergeant Morrison survived the war. He continued in engineering roles and eventually worked as a bridge inspector in Queensland. Colleagues noted his cautious standards. Captain Whittington returned to duty after recovering from malaria. He was promoted. In February 1943, during another river operation in Papua, he was killed while supervising demolition to prevent enemy use of a crossing. His body was not recovered. The 2/6 Field Company completed dozens of additional projects during the campaign: roads, fortifications, more bridges. Their casualty list grew, but their role remained largely unpublicized compared to frontline infantry units. At the original crossing site, later temporary bridges were built and washed away during wet seasons. Decades later, a modern concrete bridge stood downstream. A small memorial plaque was installed in 1992, seldom visited due to the remoteness of the location. During dry periods, remnants of the original foundation cribs could still be seen embedded in the riverbed, aligned despite decades of floods. The story of the Kumusi crossing illustrates the practical nature of war. 68 hours of construction, 63 minutes beyond predicted structural endurance, 34 lives lost, 6,000 preserved. The event did not change the course of the entire war alone. It ensured continuity at a critical moment. It preserved operational momentum when delay might have reversed months of effort. Bridges are built from calculation and material. On the Kumusi River, calculation met necessity under fire. The structure failed exactly when its purpose was complete. For a brief window on a November morning in 1942, timber and rope carried an army. That was enough.